Happy Thursday, guys. One more day from Friday. So some of you are saying this is taking forever. I'm going to show you today a quick way where you could have looked at this and said, oh, I know the answer, and got the product like that. And then you could have looked at this and go, oh, that's the square of a binomial, and got the answer like that, and then brought down the 5. And then put these two together in a box, and you're done. Well, put these, you could have distributed the 5 and then put those in a box together, and you're done. Right? It really is that simple. But you're like, mister, I don't know the shortcuts yet. You didn't teach us the shortcuts. So if I were you, what I would have done is I would have combined the ones that kind of look similar. You see how these two are similar? X plus 3, x minus 3, right? And so if you do this in a little box, right? X and 3 and x and negative 3, right? X plus 3 is this side, x minus 3 is this side. And then we just do the product of each box, or the area. This is called the area model because we're basically finding the area of each box, and then we're just adding them all together to get the area of the whole thing, because area is length times width or base times height. So it's basically multiplying polynomials, but doing it in a visual form. So x times x is, come on, dude. There we go. X times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x, and 3 times negative 3 is negative 9. And what do you notice about these two? Yeah, did you notice? See, this is the thing about algebra. A lot of you complain that algebra is so complicated. Algebra makes things more complicated. Why can't we just keep it easier? When in actuality, algebra makes things simpler because they look for patterns. They look for things that keep happening. Right? And then they go, oh, and then they generalize those patterns, and then that's how we get formulas and stuff, and that's how we get shortcuts. If you recognize things that are happening, patterns, then you can start, they cancel out, 3x minus 3x. So did you notice these two binomials look almost the same, but one has a plus and one has a minus. The x and the 3 are exactly the same, but one's a plus and one's a minus. Right? Those things have a name. And when we multiply those things, that middle term cancels out, and we just get x squared minus 9, which also has a name, right? Which we'll talk about later. So x squared minus 9. And then you could have looked at this and say, oh, x minus 4 squared just means x minus 4 times x minus 4. And if I did a little box there, hey, wait, mister, I'm noticing a pattern right here. Hold on. These two binomials look the same, but one's plus and one's minus. So that middle term canceled. Over here, I have two binomials that are exactly the same. They're both minus. I wonder what's going to happen. So I'll put x and minus 4 here, x and minus 4 here. Very similar, but this time they're both negative. I wonder. And this is where people looking at patterns think, okay, over here, these two canceled. I wonder if this is those wonderings, right? Ooh, I wonder if those are going to cancel here too. Let's see. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. These two don't cancel out. They actually double up. They're actually exactly the same. I wonder why. There's that wondering again, right? I wonder why. I wonder. Right? So these are both the same because these are both the same. These are both different because these are both different. Okay. So then this becomes x squared minus 8x, right? Because we double up, plus 16. So I have x squared minus 9 as the result of these two. I have x squared minus 8x plus 16 as the result of these two. And then don't forget I have a 5 right here. Let's bring down that 5. Okay. After today, you're going to bypass all of this work. After today, after I show you those special products, you're going to look at this and put this immediately. And then you're going to look at this and put this immediately without any of the work. What are you saying, mister? You mean I'm going to go from here to here with absolutely no work? That's right. That's right. And this one too. I'm going to do that, look at that, and go directly here without any of that work. Yeah. And you know why? Why? Pray tell why, mister. Because of algebra. Because of patterns. Because of recognizing patterns in things that you look at and the common things you see over and over and over and over again, right? So now there's no shortcut for this one. This one I'll just distribute the 5 here. You can distribute the 5 here if you wanted to, but I'll just multiply these two because just remember when you multiply 3 things, and that's what I'm doing here. I'm multiplying 3 things. 1, 2, 3. I'm multiplying 3 things. So when you multiply 3 things, I can multiply, the commutative property says I can multiply any first. I can multiply them in any order. So what I'm going to do is I'm going to distribute the 5 to this one. So it's going to become 5x squared minus 45. And this is x squared minus 8x plus 16. And so now to multiply those two, I'm going to do a 2 by 3. Why a 2 by 3 box? Because there's 2 terms here, binomial. And there's 3 terms here, trinomial. So here's my box. 2 on this side and 3 on this side. So my binomial is 5x squared minus 45. And my trinomial, hold on, my 5 is horrible. And my trinomial is x squared and minus 8x and 16. And so now let's combine. Let's find the area of each box. So 5x squared times x squared. Well, 5 times 1, because there's a 1 there, is 5. And x squared times x squared. Remember, when you multiply 2 variables, you add the exponents. So it's x to the 4th. So 5x squared times negative 8. So 5 times negative 8 is negative 40. X squared times x to the 1st is x to the 3rd, right? Add those exponents. 5x squared times 16. Well, what's 5 times 16? 80. And then x squared times, there's no x there, so it's just x squared. And then negative 45 times 1x squared is negative 45x squared. Negative 45 times 8x to the 1st. So we have to get our handy-dandy calculator because I don't know if you know that. Uh-oh, my handy-dandy calculator turned off. There we go. So do we know 45 times 8? So negative 45 times negative 48 is going to be positive 45 times 8, which is 360, x to the 1st power. And negative 45 times 16 is negative 720. So now let's get all the like terms together. Now they don't line up nicely like they did before because I only have 2 here and 3 here. So they're not as nicely aligned, but we can still see x to the 4th. So start with that one, 5x to the 4th. And then I have an x to the 3rd right here. I don't have any more x to the 3rd. So it's minus 40x to the 3rd. X to the 2nd. Oh, I have 2 of them here. I have that one and that one. So negative 45 and positive 80. So what's 80 minus 45? And that's 35, so positive or plus 35x squared. X to the 1st is right there. I only have 1, plus 360 x to the 1st. And then my constant, only have 1, minus 720. And we are done. And we are done. Okay. Any questions? I know this is blurry. Do you want me to zoom in on any one part? So first thing we did was I multiplied these two together because they look kind of similar. When when I do math, when I see a big problem, I like to do the things that look similar, right? So I did those two first. And I did the box method, and I got this. Okay? Again, I'm going to show you a shortcut where you can even skip all this. And then next, I said, okay, this, x minus 4 to the 2nd. That's just x minus 4 times x minus 4. So we did the box method, and we got this. Right? And again, I'm going to show you a shortcut where you can skip all this work. And then the 5 is just there. Then I distributed the 5. And I got this. And nothing happened to this. And then I multiplied those two together using the box method, and I got my answer. So hopefully you're looking at this and going, oh, that's not as bad as I thought. That's actually more simpler than I thought. You know why? It was that lizard brain right here. That lizard guy right that lives in the base of your brain, you know, your amygdala. It was the fear that made you go, I can't do this. This is too difficult. It's taking too long. I don't want to do this. Right? It's that amygdala saying, I don't want to do this. Let's just not do it. Just watch Mr. do it. Not even try. And that's bad. You need to try. You need to try. Dance with that fear. So are there any questions on any specific thing I did? Those of you that got it wrong, do you see where you did this? Now, could you, a question comes up, hey, mister, what if I multiplied this times this first? And then I multiplied this times this to one of these. And then I multiplied this times this. And then I multiplied those together. Would I get the same thing? The answer is yes. You'd have a big, huge mess, and it'd be a lot more difficult. But yes, you would get the same exact thing. It's kind of like if I multiplied 5 times 2 times 10. Right? If I multiply 5 times 2, which is 10, and then times 10, I get 100. But if I multiplied 5 times 10, which is 50, and then times 2, I get 100. Or if I multiply 2 times 10, which is 20, times 5, I still get 100. So it doesn't matter what order I multiply my things in, right? But sometimes with polynomials, it's easier when you find shortcuts or patterns or things you've seen before. Like this right here, you should have saw and said, oh, those are conjugates. And then you look over here, oh, that's the square of a binomial. I know how to do that instantly. And you go instantly here, distribute, box method, done. Okay, questions? Try different numbers because I doubt. No, you doubt and you will be wrong. This is called when you add or multiply. When you add or multiply, it doesn't matter what order you do it in. You can choose any numbers you want. It works for all numbers. Right? Commutative property means you can change the order and you'll still get the same answer. And this, the commutative property of addition, so it works for addition, and of multiplication. This is why teachers in 5th grade, 6th grade, 7th grade, 8th grade have always told you these properties. And then you guys roll your eyes and go, oh, these properties again, commutative property, associative property, distributive property. But you guys latch on to distributive property. You guys latch on for a distributive property, but you don't latch on to commutative property or associative property. Well, you can change the groups now. You can change the grouping, right? So give me 3 numbers. Give me 3 numbers. I'm going to prove. So she doesn't believe me. Does not believe me. Let's try. Give me any 3 numbers. Give me numbers where you think it's going to break it, where it will not work. Because I love this. This is what you need to do in math. You need to question. You need to question the rules, right? Why does it work? Why does it work for multiple? Okay, yes for addition, but why multiplication? Okay, give me 3 random numbers. Anybody? Anyone just give me a 13, 8, and 5. Okay, so let's do it in order. What's 13 times 8? 13 times 8 is 104. And 104 times 5 is 520. Okay. Try this, then let's do 13 times 5 first, then 8. Okay, what's 13 times 5? 65. And what's 65 times 8? Oh, 520. Oh, yeah? Well, try 13 times, try 5 times 8 first. Okay. 5, 8, 13. So 5 times 8 is 40. And 40 times 13 is 520. Okay, so it works for any number of numbers. You can multiply in any order, get the same answer. You can add in any order and get the same answer. Yeah. Don't you remember commutative property and associative property back in 4th, 5th, 6th, 7th, 8th grade? That's always the beginning That's always the first weeks of lessons when you learn the properties over and over and over again. Right? Associative property is basically the same thing. If I have A times B times C, I can do those first. Or I can do those. Or I can do like that, change the order and change the groups, and it works. So yeah, so okay, good. So yeah, so it works, and that property works with polynomials. Okay, so let's look at adding, subtracting, now multiplying. Now we're going to look at special products. So the first special product we're going to look at are called multiplying conjugates. What the heck is a conjugate? Conjugates are just I guess that's the best way. Binomials with opposite signs. So A plus B and then A minus B. So the numbers, the terms inside, so these are exact binomials. So I guess this is a good way. This is the way I can say it, but if they're exact binomials, but one's positive, one's plus, and one's minus. Okay. So when you multiply conjugates, so these are conjugates right here. When you multiply these conjugates, you get what's called the difference of two perfect squares. Right? Remember we did this in the warm-up? Right? Remember we did this in the warm-up and that middle term canceled out? Why did that middle term cancel out? Because one was positive and one was negative. So they canceled each other out. So let me show you what I mean by this. So you can do this quickly. So if I gave you x plus 7, x minus 7, if we did this the long way, we would make a box, a 2 by 2 box. And we get x plus 7, x minus 7, and we would get x squared minus 7x plus 7x minus 49. This middle term always is going to cancel out. Because of this positive and this negative. So we're always going to get this first term squared and the last term squared, and then subtraction because one's positive, one's negative. So we're always going to get the first one squared minus the second term squared. Always, always, always. You don't believe me? Try it. Let's try one. Let's try x minus 9, x plus 9. My guess is it's going to be x squared minus, what's 9 squared? 81. That's my guess. Do it the long way. X minus 9, x plus 9. I guess it's going to be x squared minus 81. Try it. Yes, it does work. Right? Try another one. How about x minus, what do you want to put? I don't know. X minus 6, x plus 6. Those are conjugates. How do you know those are conjugates? Because they're exactly the same. They're exactly the same binomials, but one's positive, one's negative. We're going to be using conjugates a lot. So you did in Algebra 1. Those of you that had me for Algebra 1, yes, we did. I taught you all this already. And if you forgot, it's okay. 2020 was the longest year of our lives, and we forgot a lot of stuff, so it's okay. So what do you predict this is going to be? It's going to be x squared, right? That first one squared. The middle term is going to cancel out. Positive 6x minus 6x, right? Positive 6x minus 6x. Going to cancel out, so we're not going to have that middle term. And then we're going to have minus 36. The difference of two squares. That's it. What about x minus w x plus w. Oh, mister, you're being mean. I don't understand that one. Well, it's going to be the same thing. It's going to be the first thing squared. So what's the first thing? X squared minus the second thing squared. What's the second thing? W. W squared. Right? That's all you do. When you have conjugates, it's always the first thing squared minus the second thing squared. Like that. So when you see conjugates, immediately do them. No work. First thing squared minus second thing squared. Give you one more. What about x plus happy face, x minus happy face? That's right. X squared minus happy face squared. Now let me throw a couple at you because you're going to see few and you go, Mister, it's not the same thing. Yes, it is. What if I told you 7 minus x, 7 plus x? What would you get? Those are conjugates because they're exactly the same. But mister, the x isn't first. Doesn't matter. The x does not always have to be first. As long as you have two things, they're binomials. If they're both exactly the same, they're conjugates. With opposite signs, they're conjugates. You're right. It'll be 49 minus x squared. Right? First one squared minus second one squared. Got it? Okay, next one. Next one is the square of a binomial. If the square of a binomial, that means I have a binomial, right, and I'm putting it to the whole thing to the second power. And we saw this in the warm-up too. Instead of those middle terms canceling out, we had those middle terms twice. So here is the shortcut. This is the generic shortcut. Right, for plus and for minus. So all you do is you still have the first one squared and you still have the last one squared. But in the middle, instead of the middle canceling out, the middle is double this times this. And let me show you what I mean. So if I had x plus 3 squared, let's do it the long way. Right, let's do it the long way so you can see what's going on. So I have x plus 3, x plus 3. They're both exactly the same. So I get x squared. 3 times x is 3x. 3 times x is 3x. 3 times 3 is 9. Okay, so what happens to these middle terms? There's two of them. They're not opposites. They're the same because I have the same sign. Because x plus 3 squared means x plus 3 times x plus 3. So now I get x squared plus 6x plus 9. And if you notice, this first term is just this one squared. This last term is just the last term squared. And this middle term is just this and this doubled. Okay, that's the square of a binomial. Right? The first one was multiplying conjugates. Somebody asked, what was the first one called? Multiplying conjugates, right? When they're opposite signs. This one is squaring a binomial. So let's see if you understand what I'm talking about. So let's try one. What about x minus 7 squared? Okay, I'm squaring a binomial. So let's think about the pattern. So I'm going to have the first one squared. Then I'm going to end with the last one squared, plus 49. Right? And so what goes in the middle? This times this, doubled. So negative 7x. I'm going to have that twice, and it's going to become minus 14x. Just this and this together, doubled. And that's it. That's how you square a binomial in 2 seconds, maybe 3 seconds. Get it or no? We can try another one. Mister, try another one. Okay, how about x plus 9 squared? Try it. It should have taken you a few seconds, right? You're going to get a trinomial. The first one is the first thing squared, is this squared. The last thing is this squared. So positive 9 squared is positive 81. And the middle is just this and this together, right? 9x. But double it, because you're going to have two of them, right? You're going to have two of them, so plus 18x. And I'm done. Right? Without having to do it the long way. Now, some of you are looking at this and going, Mister, and this happens every year, I show these two shortcuts. Right? And these are very powerful shortcuts. It helps us save a lot of time with some of this multiplying. And then it's also going to help us factor, because you can go backwards. But some of you still say, Mister, I don't get these shortcuts. Can I just do it the long way? And my answer is, yeah, you can. You can still do it the long way. But I recommend you try to learn these shortcuts to make your life a little easier. But if these shortcuts do confuse you and you do see like x plus 7, x minus 7, and you have to do this, then go ahead. Hopefully, and this should have happened in Algebra 1, hopefully you do enough of these where it just becomes like, oh, okay, yeah, okay, I get it. That middle one is always canceling out. Hopefully when you're doing this all the time, you keep seeing that this cancels out and you're only left with that squared and that squared. You see, oh, it's a difference of two squares. Okay, that's what happens. Right? And then when we factored last semester, we kind of did talk about this already. When you have the difference of two squares, you can go backwards and they come out to conjugates. So we will be factoring. Factoring is not going away. It is not going away. There is a third shortcut, but this is not very common. This is if I cube a binomial, I have this pattern. This is not as intuitive, and I don't expect you to memorize this. You could go back to your notes and look at this, but when I cube a binomial, it goes in this pattern. Okay, I don't expect you to memorize this. If you want to do like x plus 3 cubed, right, it's going to be something squared plus 3 something squared something plus 3 something something squared plus something squared. And then you just put everything in there. This is your A, this is your B. So you put x and 3, x and 3, and then 3. And so it becomes, cubed. X cubed plus, what's 3 times 3? Right here, 3 times 3 is 9x squared. Plus, what's 3 squared? 9. So 9 times 3 is 27x. Plus, what's 3 squared? 9 plus 9. So this is a shortcut for cubing a binomial. Not many students like to memorize this one because it's not easily memorizable. It's not because it doesn't connect. This one is easy memorizable because of the two terms you have, right? Because of the two terms you have, and that they're the same, so that's why this doubles in the middle. This one is easy memorizable because those two terms in the middle cancel, so you only have the first and the last one squared. So those are easy to memorize because you can see why it happens. This one, not as easy. Not as easy. Next week, we are going to talk about Pascal's triangle and how to do this kind of binomial to any power. So you'll see the pattern there. But if you don't memorize the cube of a binomial right off, that's okay. But the formula is here if you do want to do something plus something cubed. This is the pattern. Okay, but if you just want to do it the long way, like if you just want to do x plus 3 cubed the long way, it's just x plus 3 times x plus 3 times x plus 3. And just do these two first. And then once you get that, oh, I can do those two. That's the square of a binomial. That's x squared plus 6x plus 9, right? Because that's the square of x plus 3. And then multiply it to another x plus 3 using a box method, and you're done. So, and you'll get this answer. Okay, so the cube of a binomial, it's there, but I don't expect you that one to just like come off the brain really easily. The other two I do. The other two, they should because of how they're built. This one has the same thing twice. This one has canceling in the middle. And so those are a little bit more to memorize. Okay, so let's try to get our homework done tonight. Class is over, guys. It is 11:45. I'm sorry.